12.4 is on simplifying rational expressions, and before we jump right into simplifying rational expressions, it's important to get some terminology out of the way. So just as a reminder from earlier in your mathematical education, a rational number is just any number that can be written as a fraction. So where you have a numerator and a denominator that are both integers. So 8 over 2, that's a rational number, that would just be 4. 1 over 5, that's a rational number. 7 over 1 is also a rational number. So anything that can be written as a fraction is a rational number. So if we're talking about a rational expression now, that's just a fraction whose numerator and denominator are both non-zero polynomials. So it's the same idea. Here we just had monomials, but we could also have binomials, trinomials, etc. So 3 over x plus 4, this is a rational expression. 2x over x squared minus 9, that's a rational expression, so is 4x plus 1 over 2. Anything that can be written as a fraction where your numerator and denominator are polynomials would be rational expressions. So 12.4 deals with simplifying these. Another definition to get out of the way is an excluded value. And an excluded value is an x value that would make the denominator 0, which makes the entire expression undefined. So for example, an excluded value for 3 over x plus 4 would be where x is equal to negative 4, because negative 4 plus 4 is 0, and you can't divide by 0. So the idea is an excluded value is any x value that makes the denominator 0. And we say that a rational expression is simplified if the numerator and denominator have no factors in common. Okay, so to simplify, it's helpful to factor the numerator and denominator and then just cancel any common factors. And we can only cancel by dividing if the common factors are being multiplied by on both the top and the bottom. So if they're being added, you can't do that, but if everything's being multiplied, then you can simplify. So let's start off doing something that you've done before. This is a rational expression. It's just a typical fraction, what you're used to seeing. And to simplify this, you might know right away that this is 4/5, but if not, you said, okay, 28 is just 4 times 7. 35 is just 5 times 7. You maybe wouldn't have written this out, but this is what you would be doing in your head. And then you said, oh, well, there's a 7 on top and a 7 on bottom, so we're left with just 4/5. So we're going to use this same idea of simplifying basic fractions to simplify rational expressions. So here we have 8x over 3x. Well, 8 and 3 don't simplify, but 8 is being multiplied by x and 3 is being multiplied by x, so we can actually cancel out or simplify these x's, because x over x is just 1. So our simplified version of 8x over 3x is just 8 over 3, and we're done. Looking here now, we have 3 times the quantity x plus 4 divided by 15 times the quantity x plus 4. Now, you might be tempting to distribute this 3 and distribute the 15. But what's our general process for simplifying is to factor, and this is already factored. So we have 3 times x plus 4 and 15 times x plus 4. So by the same logic we used here, we can actually cancel these x plus 4s. This is entire quantity being multiplied. Now we're left with just 3 over 15, but we know that fraction simplifies to 1/5. So really, this entire quantity, this entire expression can simplify to 1/5. Okay, let's try a couple more. We have x times x squared plus 6 divided by x squared. Now this is where it can be very, very tempting to say, oh, I have an x squared and an x squared, I'm just going to cross those off. But the issue with that is x squared is not being multiplied by 6. X squared plus 6 is its own quantity. This will always have to be grouped together. So we can't just take out the x squared. This was our rule. We can only cancel by dividing if common factors are being multiplied on both the top and the bottom. So we can't just cancel those x squareds, but here's what we can do. X squared is just x times x. So maybe if I just rewrote this as x times x squared plus 6 divided by x squared is just x times x, you might see now that you have an x multiplied on top and an x multiplied on bottom. So we can actually cancel out one of those. Now we're left with x squared plus 6 divided by x. And here we can't simplify anymore. We're done because nothing is even being multiplied on top. This x squared plus 6 is its own piece. So we can't simplify this x squared with this x. So we're done. Let's look at another one now. Here again, it might be tempting to say, oh, x squared, cancel them out. 6, cancel them out. But that's not a legal move because these things on top in the numerator are not being multiplied. But our process is to factor the numerator and factor the denominator. So what can we factor out of the numerator? We have a 2 and a 6, so we could factor out a 2. We have an x squared and an x, so we can factor out an x. And we're left with just x minus 3. And then divided by 6x squared. Can't do anything else there. Well, now we can simplify 2 and 6. We can simplify x and x squared. So we're left with x minus 3 on top. On a bottom 2, 6, we'll be left with 3. X squared will be left with just x. So we have x minus 3 divided by 3 times x. We can't simplify this x and this x and this 3 and this 3. Nothing's being multiplied on top. So we have to leave it as is, x minus 3 divided by 3x, and that's simplified. So let's look at these excluded values. We're just asked not to simplify here, but just ask for what values of the variable is the rational expression undefined. So here you're just looking at what makes the denominator 0. So you can do this the long way and set 0 equal to 2 times x plus 5. Divide both sides by 2. 0 divided by 2 is still 0. When we divide the right side by 2, we're left with just x plus 5. Subtract 5. X is negative 5. Now, you don't need to go through that process every single time. You could just look at this and say, oh, if x is negative 5, this would go to 0, so the whole denominator would go to 0. That's totally fine. I actually prefer that, but I'm just showing where this comes from. For the second example, we have x plus 4 divided by x squared plus x minus 6. Now, it's not very obvious what makes this denominator 0, but oh, lucky for us, we could factor the bottom, right? So 0 equals, factoring the bottom, what multiplies to negative 6 but adds to positive 1? Well, positive 3 and negative 2. Oh, x minus 2, sorry. And then we know from solving this from chapter 9 that x has to be equal to negative 3 or x is equal to positive 2. So notice that the numerator does not make any difference here. We're just looking for excluded values. So x could not be negative 3 or x could not be positive 2. Looking at the bottom of this one here, we have x squared minus 49. We want to know the x values that make that 0. You might see right away that you'd have 7, but just remembering how to factor x squared minus 49, that's a difference of squares. So we have x plus 7 times x minus 7. X squared minus 49, x squared is a perfect square, 49 is a perfect square. So the values of x that make the denominator 0 would be where x is equal to negative 7 or x is equal to 7. So you're just looking at the denominator when you're looking for excluded values. Okay, so here we're going to put it all together. We're first going to identify any excluded values, and then we're going to simplify the expression. So before we do anything, what would be an excluded value of this first example? What value of x makes the denominator 0? 20 times what gets you 0? Well, that would be 0. So we say that x cannot be 0. This is just an equal sign with a slash, so it's saying x cannot be 0. And now let's simplify. 5 divided by 20 can simplify to 1 over 4. X squared divided by x could simplify to just x. So 5x squared divided by 20x is just x over 4. And once again, that came from x squared canceling with x, 5 canceling with 20, 4, and 1. So we have 1 times x divided by 4. Okay, let's look at this example here. First of all, what are our excluded values? We have x times x plus 3. Well, right away we know x can't be 0. Because 0 times, well, if you plug 0 in for x, you get 3. 0 times 3 is still 0. X also could not be negative 3, because negative 3 plus 3 would give you 0. 0 times negative 3 is still 0. So now that we have that out of the way, what can we simplify? We have an x plus 3 and an x plus 3 on top and bottom, so those can go away. And we're left with just x minus 2 divided by x. And remember, you can't cancel this x and this x because these two things are not being multiplied. They're being subtracted. All right, one more here. What values of x make this expression undefined? Remember, you're just looking at the denominator. What value of x do you need to plug in to make the whole thing 0? And that would be negative 2. So x can't be negative 2. Now let's do some simplifying. X plus 2, x plus 2. 4 over 2, we know is just 2 over 1. So simplifying this whole expression, we just get 2. As long as x is not negative 2, we'll get 2 back. Okay, last two examples, but they do get a little bit trickier. We're asked to do the exact same thing. Identify the excluded values and simplify. Let's start with the excluded values. What can't x be in this example? We have 4 minus x in our denominator. 4 minus what gets you 0? Well, x can't be 4 because 4 minus 4 gives you 0. But now simplifying this is not as easy as these last few. We have x minus 4 divided by 4 minus x. They look so similar, but they're definitely not the same thing. Here's the trick we can do. It's not always very obvious, but if you ever have something like this where things look similar, but maybe the order is mixed up, you can always factor out a negative 1. I'm going to show you what I mean. We'll leave the numerator the same, x minus 4. Now in the denominator, what we're going to do is we're going to pull out a negative 1 from each of 4 and negative x. So we're going to have negative 1 on the outside. And on the inside, what we're left with is going to be a negative 4, because negative 1 times negative 4 is positive 4. And we'll be left with a positive x, because negative 1 times positive x is negative x. Now what I'm going to do is just rearrange the order of negative 4 plus x. So the top will stay the same, x minus 4 divided by negative 1 times, rearrange, x minus 4. Oh, look at that. Now we have an x minus 4 and an x minus 4. So we can simplify those. We're left with 1 over negative 1, which is just negative 1. So this move is not a very obvious one, but it is a very legal mathematical move that can help you simplify. So the trick is whenever you think things look similar but are mixed up, maybe in order, try factoring out a negative 1. Let's look at another example. I'm going to give us some more room here. We have 12 minus 5x divided by 10x squared minus 24x. Well, the first thing we want to do is factor the top and bottom. The numerator can't be factored anymore, so we're still left with 12 minus 5x. But in the denominator, we have 10x squared and negative 24x. We could factor out a 2. We could also factor out an x. So now we're left with 5x minus 12 after we factor out 2x from each of those. And here you might notice we have a 12 minus 5x in the numerator and a 5x minus 12 in the denominator. So you guessed it, let's factor out a negative 1 just from here. So what's going to happen is we're going to make this negative 2x instead. And then we're going to make this a negative 5x plus 12. So our new denominator is negative 2x times negative 5x plus 12. Rearranging the order now, we'll keep the numerator the same, 12 minus 5x divided by negative 2x. All we're doing now is switching these. 12 minus 5x. And here we go. Now we can start simplifying. 12 minus 5x, 12 minus 5x. We're left with just 1 over negative 2x. And this is our simplified version. We just changed our denominator by factoring out a negative 2x instead of a positive 2x, and then things simplified fairly easily. So that wraps us up for 12.4.